one side of the Meilerwagen. The outlet of the alcohol pump was connected to one of two permanent delivery pipes fitted to the elevating arm of the Meilerwagen. This delivery pipe extended the whole length of the Meilerwagen arm, and the alcohol was fed in through the control compartment to the top of the alcohol tank. Now the alcohol filling started. It took about 10 minutes to fill the alcohol tank in the rocket. The liquid oxygen trailer was the next fueling vehicle to arrive at the launching site. The Germans always tried to fuel the liquid oxygen within an hour of the time of firing the rocket, to avoid freezing up the valves. This arrangement of fueling vehicles round the Meilerwagen was a typical German layout. As well as the alcohol and oxygen vehicles on either side, the T-Stoff vehicle is directly in front of the rocket. The liquid oxygen is fed in at the middle of the rocket. The pump is connected to the permanent delivery pipe on the arm of the Meilerwagen. The sodium permanganate is the last fuel to go into the rocket, and at this stage it is placed in an electric heater to warm it up. The reaction between hydrogen peroxide and sodium permanganate, which produces the steam for the rocket turbine, is quickened if the sodium permanganate is warm. By now, the oxygen fueling is in full swing, and the pipes through which the liquid oxygen is traveling begin to show the characteristic formation of ice and snow. The oxygen fueling took about 8 minutes to complete. Now that the alcohol fueling of the rocket was finished, the pump was disconnected and the alcohol bowsers began to move off. During the oxygen fueling, the hydrogen peroxide is pumped into the steam unit. It is first pumped into a measuring tank fixed halfway up on the arm of the Meilerwagen. From this point, a measured quantity of hydrogen peroxide is run into the tank inside the rocket. Hydrogen peroxide is a corrosive fluid. The men who handled it wore rubber gloves, and the connecting joints of the pipes which carried the fluid were placed in buckets of water. Every now and then, the sodium permanganate, the other element used in producing the steam, was taken out of its electrical heater and shaken to mix it up and make it more effective. As the fuel tanks are filled, the weight of the rocket increases and the joint between the tank section and the tail unit needs retightening. An elevating ladder is used to get a member of the firing troop up to the joint. There is a danger that the coldness of the liquid oxygen might freeze up the rest of the machinery. So, to make certain this didn't happen, hot air was blown up through the rocket from an air blower. The Germans did this only if there was a hitch in the preparation and the rocket could not be fired within an hour of the oxygen fueling. As the job of each fueling vehicle was finished, it was driven away from the launching site. The oxygen fueling is almost completed, and clouds of condensed water vapor are pouring out. When the liquid oxygen tank has been filled, the connecting pipes are removed with the aid of a hammer. Once again, special gloves are worn for the operation. Just as the liquid oxygen fueling is finished, it is time to start the Z-Stoff fueling. The sodium permanganate is removed from the electrical heater and taken to the rocket. Now the sodium permanganate is lifted up the side and tipped into the tank through an opening in the tail unit. Next, the igniter is prepared. The wooden framework, which is fixed inside the venturi and supports the igniter, is put together. The igniter works like a large-sized Catherine wheel and is started electrically. Now that the fueling is finished, the arm of the Milewagen is lowered. The rocket is finally leveled and orientated in the direction of the line of fire. This is done by using a dial sight on the launching table, having as a reference a collimator set up over a trig point a few yards away. The trig point was established by preliminary survey. The igniter is placed in the venturi and connected up. Then the firing troop take cover in the slit trenches they've dug near the rocket. The troop commander goes to the firing control vehicle. The control panel from which the rocket is fired is in this vehicle. The final steering tests are made. And then the firing troop commander gives his orders.
Ist Steuerung klar? Ist klar. Ist Triebwerk klar? Ist klar. Schlüssel aufschießen? Schlüssel steht aufschießen. Durchschalten. Ist durchgeschaltet. Belüftung klar, Zündung klar, Vorstufe klar. Hauptstufe gegeben, Stecker gefallen.
When the rocket reaches an altitude of 40 to 50,000 feet, a vapor trail condenses in its wake, just like the trail made by high-flying aircraft. The effect of the rocket going down is an optical illusion caused by the angle of the camera which shot this scene. The rocket's still going up all right. Now we see the operation in slow motion. When the troop commander says "Durchhalten," the igniter is lit and the alcohol and liquid oxygen, which are flowing under gravity, are ignited. This gives a thrust of 8 tons, which of course won't lift a 12-ton rocket. The troop commander looks at the flame to see that it is burning evenly. When he sees that it is, he gives the command Hauptstufe. This starts the pumps. The thrust from the jet increases rapidly up to 25 tons. The control cables are ejected electromagnetically and the rocket takes off. This is a close-up in slow motion of the rocket leaving the launching table. was the first operational model of a new conception, complicated to produce and not very accurate or reliable in action. But it was extremely difficult to counter. And to the Germans, its range of 200 miles was only a beginning. They were already thinking of a rocket that would cross the Atlantic and could be guided to a controlled landing by a pilot in a pressurized cabin. We cannot afford to be complacent about the rocket and its potentialities in the future. The record of this film is a warning that we've got a lot to think about.